I'd like to introduce Tom Netwick. Tom is my good friend from many years ago. He owns Extrusion Supplies in Youngstown, Ohio. Tom is an expert in soft alloy extrusion, aluminum, and other soft metals. And today we're going to talk about the process. What is aluminum extrusion? What is this all about?
Well, David, thanks for having me. Aluminum extrusion in its simplest form would be a tube of toothpaste, for instance, and you're pushing the material in the tube through a hole on the end, and it comes out and goes right on your toothbrush.
So it's essentially squeezing something through a die, right?
Yes. In the aluminum extrusion process, it's heating up a billet and pushing that billet with a lot of pressure through a die that is formed to the application that you want to come out the other end.
So you're telling me that we're going to take a solid piece of metal or we're going to jam it through something and it's going to come out of shape on the other side?
Exactly.
Come on, man, that's metal. You can't do that. How many tons of pressure does it take to push that stuff through there?
Well, it just depends upon the alloy and the size of the profile that you're pushing. So a lot of times you'll have 100,000 PSI on the face of the die as you're extruding.
That's a lot of pressure.
That's a lot of pressure.
Walk us through the components of how that actually works. It can't be just pushing it through, right? There's got to be parts to it. The reason I ask is we have a lot of appraisers that watch this, and some of these guys have never seen an extrusion press, so they can use this and learn something. So walk us through the components, and we've got some images.
Well, yes, you have a press and you have a handling system. And you start off with a log that's at varying long lengths, and you push that through a heater, and it exits the exit side of that heater, and it feeds into a shear. And that shear will shear it off into short billets, and the billets will drop down into a billet loader. That loader will take it into the press itself in front of the ram, and there's a container there that will close over the top of the billet. The ram will push that billet through that container and then through the die. And as it exits the front of the press through that die, it'll come out in the shape that the die was made to accommodate.
That's really cool. I'm going to share this photograph of this Xtrol Technology press that you had installed at one of your customers. What are the components we're looking at in this picture?
Well, on the right side of the picture, you've got the shear that I mentioned. So as the log comes forward, it's sheared off. At that point, the log is at about 850 degrees. It's sheared off, drops into that loader. The loader moves forward into the equipment, as I mentioned earlier, and the billet sits in front of the container. The container closes over the billet. The ram moves in this picture from right to left. As it pushes it through, the die sits on the front side of that container. You'll have frictional heat build up. So as it exits the die in the front of the press, it'll be about 1,000 degrees. And then some pullers will grab it to assist it down the table. And it'll run a couple hundred feet down the table, and it'll be cooling the entire time. And then it'll move across the table as it cools over to a stretcher, which at that point, it should be ambient temperature. Stretch the material, move it over in front of a saw, and then cut it to length. After that, actually, it has to go through an aging process. Aluminum will naturally harden with age, but we take it through an artificial aging process, which is feeding it through an oven at an average of 350 degrees for anywhere from 5 to 10 hours, depending upon the application. And then when it exits, it's hard material, and you can be fabricated from that point.
From the toothpaste tube to the hardened material, that's a really cool process.
It is.
Tommy Netwick, Extrusion Supplies, Youngstown, Ohio. You are a great man. Thanks for joining me today.
Thanks, David.